Okay, in this video I want to do a very quick, brief, high-level overview of the difference between an ERC20 token and an EOS token. So, as we've discussed in a previous video about kind of the high-level concept of Ethereum, there are these addresses, and these addresses can hold balances, but they can also hold smart contracts. So that was the initial idea, and the ICO craze kind of motivated this idea, the necessity for this ERC20 token standard. And the token standard is essentially just like assume that if your token adheres to these method calls, then any wallet can interface with it essentially. So the way, and we'll look at the actual Solidity code in the next video in order to kind of map what Ethereum syntax looks like, or sorry, Solidity syntax looks like versus the EOS syntax. But for right now, so what happens when you deploy a token to the Ethereum blockchain is your token gets an address. So in this case, let's say we deployed the BAT smart contract to hold the BAT token, and that, let's say, is at 0x12 blah 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 blah. For now, let's just assume that we're talking about the prefix. So anyone who wants to transfer BAT tokens has to hit this address, and then it'll have a transfer function exactly the same way the EOS token had a transfer function. So you would say from this address, maybe my address, to this other address, hey, basic attention token smart contract, transfer this token amount from here to there. So you can see down here I've kind of did a zoom in. So I did a high level, these two contracts. This is kind of like what's happening on the Ethereum blockchain. But then if you zoom into what the actual smart contract holds, it holds a list of, or what they call a mapping of addresses to balances. And all you're doing is just altering those balances up and down as you do transfers. So let's say maybe this is the SJK smart contract on the Ethereum blockchain. Well, it's going to hold a mapping of addresses to balances, and if I want to transfer balances, I would say, okay, from 0xAB, transfer 1 SJK token over to 0xDE. So all we would do is, decrement the balance from here and increment the balance from here, assuming everyone's signing the transactions appropriately and all that other stuff. So that's how the Ethereum handles tokens, is like they're all their own smart contracts essentially. The basic attention token is its own smart contract, the Golem token is its own smart contract, the OMG, all those tokens are exactly the same token smart contract with their own addresses, and you're essentially just altering these balances up and down, and the developers of these ERC20 token smart contracts may take liberties and change different implementation styles and all that other stuff, but at the end of the day they have the same kind of interface essentially. So as we saw in the other example with the EOS token smart contract, it's very, very different. So the high level idea of the EOS token smart contract is it's one smart contract on the blockchain that everybody knows about. It has the same address essentially, and inside that token contract there is an accounts table. Why does that keep happening? There's an accounts table and there is a stats table, and we saw that the stats table holds things like maximum supplies and symbols, and the accounts table holds rows of actual balances for different users and their currencies essentially. So in this case, Bob has 10 EOS and 1 SJK. Alice has 600 EOS and no other tokens. So you would be able to see everybody's balance of every token that they're holding, all by interfacing with this one EOS token. So obviously there are pros and cons to each approach, and I'm not really going to dive into those and pick sides or anything like that, but there's a definite inherent difference between how these two things decided to handle token ownership essentially. So I wanted to go over that in a high level before we actually look at the Solidity code, because I think you need to understand how the ERC20 token standard works in order to understand briefly the Solidity code, and then that will help you map syntax from C++ to Solidity. Okay, see you in the next video.